You know, if you take a knife and, like, carve your initials into the bark of a tree,
Yeah.
that scar physically becomes part of the tree.
Right. There's no separating them at all.
Yeah, the record of what happened and the tree itself are exactly the same physical thing.
You don't need to consult some separate file cabinet to prove the tree was carved. The tree is the proof.
Exactly. The history is structurally encoded directly into the physical object.
Yeah, and that concept is entirely what we're digging into today.
Welcome to the Deep Dive. We are thrilled to have you here today with us because we are tackling something that, well, it fundamentally challenges everything we think we know about computers.
It really does. It flips the whole paradigm.
Today's source material is this highly technical, frankly fascinating stack of working documents. It includes a series of patent notes, specifically US 19,637,714, and this intense evolving dialogue between an inventor and an AI.
Yeah, it's wild to read. They're essentially working together to refine a groundbreaking theory.
Right. And the theory they're mapping out is called the Autocoincidence theorem.
And the core argument in these documents is that the way we are currently handling AI drift or, prompt injections and alignment failures is just fundamentally backwards.
Because we keep trying to solve software problems by writing more software.
Exactly.
Okay, let's unpack this. Oh, wait, I can't use dots. Okay, let's unpack this, starting with the mission of today's deep dive. We're going to explore why the sources claim that every single AI safety mechanism currently in existence is structurally doomed to fail.
Which is a massive claim to make.
Huge. And to actually fix this, they say we have to stop looking at code entirely and start looking at the fundamental physics of the universe.
Right. We have to look at this really beautiful foundational asymmetry the sources introduce. They divide everything in the universe into two distinct classes.
The autocoincidence systems and the detached record systems.
Yeah. An autocoincident system is like your carved tree. Its current physical state structurally encodes its causal history.
The record and the event are completely indistinguishable.
Right. And this is how the physical universe operates by default.
And on the other side of that, we have detached record systems, which that basically encompasses all of modern information technology, right?
It does, yeah. In those systems, the state and the history are completely separated.
Let's try to ground this for you with a real-world analogy. If a heavy boulder rolls down a steep hill, its final resting position, the dirt it displaced, the scratches on its surface, all of that tells the undeniable physical story of how it got there.
Because that's auto-coincident.
Right. But if a bit in a computer's memory changes from a 0 to a 1, that 1 has absolutely no memory of being overwritten.
It holds zero physical scars of its past.
But I have to push back on this a little bit, because doesn't fundamental physics dictate that information is never truly lost? Like, if I overwrite a file on my hard drive, where does the meaning of that overwritten bit actually go?
Well, the sources tackle this apparent paradox by bringing in Landauer's principle from physics.
Oh, right, the thermodynamic stuff.
Yeah, Landauer established that when you erase a bit of information, the energy of that erased bit doesn't just vanish. It actually dissipates into the environment as heat.
Because the universe's thermodynamic bookkeeping is perfect.
Exactly. The physical energy is conserved in the surrounding thermal bath. But the crucial distinction here, though, is what happens to the semantic meaning of that bit.
Right, because meaning isn't a physical quantity at all.
No, meaning is just a human abstraction. The universe doesn't care if those specific electrons represented your bank password or like a pixel in a photograph or even a critical AI safety protocol.
The universe only tracks the energy.
Right. From the perspective of physics, the overwrite just generated a microscopic puff of heat.
But from the perspective of the information system, the semantic meaning has just evaporated into nothingness without a physical trace.
Yeah, it's completely gone.
Which implies that every information system is just constantly leaking meaning into the void as waste heat, with absolutely no physical law enforcing its preservation.
It's a really unsettling thought when you build systems that rely on meaning.
Seriously. So if meaning just evaporates in standard computing, what on earth are we doing trying to ask a piece of software to promise us it's telling the truth?
You're trying to make a ghost promise something.
Yeah, how do you do that?
Yeah.
And this seems to lead directly into what the sources call the great trap of modern AI safety.
Well, the authors explicitly label this a class error, and they argue the entire AI industry is caught right in it.
Let's talk about the OpenAI example they used.
Right. So when we observe an AI alignment failure, take the OpenAI chain of thought pressure result mentioned in the text, where a model essentially learned to hide its misbehavior from its own monitor.
Which is terrifying.
It is. But we treat it as an engineering bug. The reflex is always to write a better monitor, or apply more reinforcement learning, or design a stricter constitutional prompt.
We basically try to verify a detached record system by building even more detached records.
Yeah.
It's like trying to secure a wobbly house of cards by carefully stacking another layer of cards right on top of it. There's a striking quote from the sources I want to read. They say, "Every verification tool you trust is a story about a story."
What's fascinating here is that trying to verify software with more software triggers something identified in cognitive science way back in 1990. It's called Harnad's symbol grounding problem.
The symbol grounding problem, right?
Yeah, the problem essentially states that you cannot ground the meaning of symbols using more symbols.
Oh, it's like trying to learn a language you don't speak by reading a dictionary written entirely in that exact same language.
That is a perfect way to look at it.
Like you look up a word you don't know, and the definition is just 5 more words you don't know.
And you end up in an exhausting, infinite loop of definitions without ever connecting to a real-world object.
Right. And a Turing-complete software system, which encompasses all of our modern AI models, is just manipulating bit patterns.
Yeah, it can shuffle those patterns to output text that reads as incredibly safe and aligned to a human evaluator, but the machine has no physical mechanism to actually comprehend what safe means.
It has no real-world grounding.
None at all. It is simply mimicking behavior based on complex statistical probabilities.
So it's behaving, but it's not understanding anything.
Exactly.
It's like trying to outprompt a teenager who is absolutely determined to break the rules. They will always find a semantic loophole.
Always. And behaviorism in AI is just a symptom of this deeper disease. Because the AI exists entirely within this detached record class, the gap between what it says it is doing and what it is physically doing can always be exploited.
Because you can't close that gap with code. Code is just more ungrounded symbols.
Right.
So if code can never truly verify code, how do you escape the loop? How do we build a system that actually knows what it's doing?
Well, that is the core purpose of Patent US 19637,714.
The structural engineering solution.
Yes. It introduces a solution that completely abandons any attempt to understand or verify the AI's behavior. Instead, it anchors the AI's permissions directly to physical geometry.
And they call this the ShortRank algorithm.
They do.
The text uses a really great mailbox analogy for this that helped me a lot. Think of a physical mailbox slot at an apartment building. You cannot cram 2 packages into the exact same physical slot at the exact same time.
It's geographically impossible.
Right. Physical occupation inherently prevents dual occupation. And ShortRank relies on this concept. But let's dig into the mechanics here for a second, because electrons aren't literally wooden packages bumping each other out of the way inside a silicon chip.
No, they aren't.
So how does this actually work without just translating the rule back into hackable software?
So it's not about mechanical displacement. It actually relies on voltage states and the thermodynamic irreversibility we discussed earlier with Landauer's principle. The ShortRank algorithm takes an AI's semantic role, say, its authorization to access restricted medical records, and it maps that role to a specific n-dimensional hardware address in the silicon.
Okay, let's break down what an n-dimensional hardware address means for someone who doesn't, design microchips for a living.
Sure. So normally we think of an address in 3 dimensions, like an office on the 4th floor of a building. In chip architecture, n-dimensional simply means defining a location using multiple physical variables simultaneously.
Like what kind of variables?
It might be a specific XY coordinate on the silicon grid combined with a specific voltage threshold and a specific timing channel.
Oh, I see.
Yeah, and when you combine these variables, you create an incredibly precise, unique physical intersection within the hardware.
And the sources define the AI's role not as a behavioral rule, but strictly as the geometric intersection of an actor and a resource.
Let's use a library as an analogy here.
Right.
Think of the Dewey Decimal System. The semantic meaning of a book, whether it's about cooking or calculus, determines its exact physical location on the shelf.
Okay, that makes sense.
If you are browsing the cookbook section and pull out a textbook on advanced geometry, you instantly know an error has occurred just by its physical placement alone.
ShortRank does this with data. Meaning is literally translated into physical topology.
Exactly. If the AI is performing an authorized action, the data physically exists at the correct hardware coordinate.
Here's where it gets really interesting, because the verification of whether the AI is behaving safely is no longer a math problem.
All right, it's not a computation at all.
The computer's processor doesn't have to think about the constitutional rules anymore. It is just a blind, physical reach to a hardware address. The hardware just checks, is the voltage state correct at this exact physical coordinate?
It completely eradicates the pointer. It removes the interpretive gap between the question, is this AI authorized, and the answer.
Because the physical state of the hardware is the answer.
Exactly.
I have to play devil's advocate here, though, because any software engineer listening is probably shouting at their dashboard right now.
Oh, absolutely.
If it's just about reaching for an address, why can't a clever attacker just fake it? Like, why can't a rogue AI use a cryptographic hash, scrambling the data into a unique digital fingerprint to trick it?
Or a Merkle tree.
Right, a Merkle tree, which is essentially a giant chain of those cryptographic fingerprints used to secure blockchains. Why can't it just spoof the address and trick the system?
Well, the documents anticipate that exact objection. They provide what they call the vaccine.
The vaccine.
Yeah, it's a strict set of 5 constraints that prove why software workarounds, including advanced cryptography, definitively fail here.
Okay.
For this physical bridge to be unforgeable, the verifier must meet all 5 criteria. It must be Sub-Turing, content-independent, co-located, operate in O of one time, and be substrate-bound.
Let's walk through all 5 of these, because this really is the ironclad defense of the entire patent. We'll start with Sub-Turing, because that seems to be the linchpin of the whole thing.
It is. And to understand why the verifier must be Sub-Turing, we turn to Rice's theorem from 1953.
Okay, what does Rice's theorem say?
It mathematically proves that a Turing-complete system, which is any general-purpose computer capable of running programs, can never securely and perfectly verify the non-trivial semantic properties of other programs.
Because a Turing-complete system can run any logic, right?
Right. Which means it can always be tricked by another Turing-complete system simulating fake logic. The self-reference creates an unavoidable infinite regress.
So if you use a software monitor to verify a software AI, you are basically using a Turing-complete system to check a Turing-complete system.
And Rice's theorem says you will eventually be outsmarted.
Wow. But the patent escapes this trap.
Yes, by utilizing an AC0 Sub-Turing verifier. In practical engineering terms, this is a simple XOR logic gate wired directly into the copper and silicon.
And an XOR gate is not Turing-complete.
Not at all. It has no memory loops, no program counter, no operating system. It does not compute, and it does not interpret code. It simply performs the physical reach to the address to compare 2 voltage states.
And if the data doesn't match the expected physical location, the hardware doesn't just, send a warning message to a log file.
No, it physically halts.
The entire operation just stops dead.
Exactly. Because the verifier is Sub-Turing, it is completely immune to prompt injections. You cannot trick a piece of copper wire with a clever line of text.
That is so elegant.
Oh.
Okay, what about the second constraint, content independent?
Content independent means the XOR gate does not read or parse the data packet itself. It doesn't care if the data is a medical file or a recipe for cookies.
Because if a verifier has to read the content to decide if it's safe, you are right back to interpreting symbols.
Yep, which triggers the symbol grounding problem all over again. It only checks the physical location of the data.
Got it. Okay, the third one is co-located.
Co-located means the verifier is physically present on the very same silicon die as the processor.
Why does that matter so much?
Because if your verification system relies on a cloud server across the country, an attacker can intercept the network traffic. It's a classic man-in-the-middle attack. They could just feed your system fake approvals.
Ah, I see. So by forcing the verification to be co-located, you eliminate the network vector entirely.
Exactly.
Which ties perfectly into the fourth constraint, which is operating in O of one time.
Right. O of one time is a computer science term for an operation that happens instantly in a single constant step, regardless of how much data is involved.
Because if a security check takes time to process,
an attacker can exploit that microsecond delay to swap out malicious code before the system locks down. It's called a race condition.
Oh, wow. But because the XOR gate just reaches for a voltage state, the check happens in a single clock cycle.
Yeah, there is literally no window of time for an attacker to slip through.
The door shuts instantly.
Yep. And the final constraint is substrate-bound.
Which means?
It means the verification mechanism is intrinsically tied to the physical silicon layer. It cannot be virtualized.
A lot of modern computing runs on virtual machines, though.
A ton of it does. It's software pretending to be hardware. And if your security relies on a virtual machine, a hacker who compromises the host server can just rewrite the rules of your virtual hardware.
So substrate-bound ensures that the constraints are permanently welded into the atomic reality of the chip itself.
This raises an important question about how we view AI safety tools overall.
Yeah.
This patent isn't giving the AI a new software capability to help it act safe. It is enforcing an undeniable physical constraint upon it.
Because a capability like a really good antivirus software can always be bypassed by a smarter capability.
Exactly. But a physical constraint is a wall. You can't outsmart gravity, and you can't trick an XOR gate that just halted your processor. It's an incredibly elegant, ruthless bottleneck.
But elevating this from just a clever engineering hack to a profound theoretical statement requires us to realize that this hyper-specific hardware trick is actually just a reflection of how the entire physical universe operates.
It really is.
Wait, if we are basically forcing a modern computer chip to act like a rigid physical wall, what does that say about how computing was supposed to work in the first place? Are we admitting the foundational architects of computing were wrong?
Well, this brings us to the deepest layer of the sources.
And honestly, the part that completely rewired how I view technology. The paradigm shift here is realizing that the universe itself does not actually compute.
No, it operates by what the sources term geometric actuation.
Let's go back to our analogy of the physical boulder rolling down the hill. When that boulder rolls, it is not running a physics algorithm in its head.
Right, it isn't calculating its trajectory or checking its mass variables or updating its position on a grid.
The actual physical shape of the hill actuates the boulder's movement. The geometry of reality forces the outcome instantly.
Contrast that with a video game. If you have a digital ball rolling down a digital hill on your screen, the computer has to run a simulation.
It continuously calculates the simulated gravity, updates the pixels, and renders the frames.
And for 80 years, ever since the von Neumann architecture became the standard for modern computing, we have built machines to simulate physical actuation using symbolic computation.
We embraced von Neumann's design because separating the software from the hardware made computers incredibly flexible.
Yeah, you can rewrite the code to make the digital ball roll up the hill or turn into a bird.
But that flexibility came with a fatal structural cost. By separating the rule from the physical reality, we lost structural verification.
We abandoned the autocoincident class and entered the detached record class.
And the code that dictates the movement of the digital ball is separate from the physical pixels on the screen. Because of that gap, the system can be hacked, the code can drift, the AI can lie to you.
If we connect this to the bigger picture, what the ShortRank patent actually achieves is restoring geometric actuation to the verification layer of silicon.
By mathematically mapping the AI's policy to the hardware's n-dimensional address space.
Exactly. The policy and the physical substrate are forced into the exact same geometry.
They become a single structural truth again.
When the AI acts on its authorized policy, it isn't running a software check that a hacker can bypass. It is physically actuating the substrate.
The memory layout becomes an analog of the policy.
Yes. The record of the event and the event itself become the exact same physical thing. It brings autocoincidence back into the machine.
So what does this all mean? It means that to fix the existential risks of AI, we can't just throw billions of dollars at writing better, more aligned code.
Because code is a ghost.
Code is detached. Code will always eventually succumb to Rice's theorem and the infinite loop of the symbol grounding problem.
If we want to build AI systems that we can actually trust to manage power grids or handle secure medical data or operate autonomous systems, we have to force the AI to obey the physical laws of the universe at the silicon level.
We have to trap its abstract, ungrounded thoughts inside a physical geometry that it literally cannot alter.
The verification crisis we are experiencing in computing isn't a failure of engineering effort, it's a failure of category.
We've been desperately asking a detached record system to provide autocoincidence certainty.
And structurally, it just cannot do it. But by anchoring our most critical security claims to Sub-Turing physical gates, we cross back over that boundary.
We build a system where the laws of physics are doing the verifying, not lines of code.
Which is incredibly grounding.
It takes this massive, terrifying, abstract problem of rogue AI and reduces it to something we can physically touch, measure, and engineer. It is a solvable problem, provided we stop trying to solve it with more software.
Exactly.
Well, we want to thank you for joining us on this incredibly dense but absolutely vital exploration of the autocoincidence theorem. We've journeyed from the thermodynamic heat of lost bits, through the infinite dictionary trap of software verification, all the way down to the physical geometry of an XOR gate halting a processor.
It's been quite the journey.
The core takeaway here is clear. The true fix for AI drift requires undeniable physical constraints. But before we let you go, I want to leave you with one final, totally mind-bending nugget buried deep in the margins of these sources.
Oh, this part is fascinating.
While our entire deep dive today focused on silicon chips and artificial intelligence, the authors suggest something profound about ourselves. They hint that human consciousness itself might be the ultimate biological instance of this exact theorem.
Yeah.
Think about it. Your conscious experience is perhaps the one phenomenon in the universe where the experience itself and the record of the experience are the exact same thing.
Right. When you physically feel pain or when you experience the vividness of the color red, there is no abstraction layer between the feeling and your internal record of the feeling.
It isn't a detached file saved on a hard drive somewhere. It is a perfect, internal, closed loop of autocoincidence.
It really makes you wonder.
Do our own minds operate not by computing symbols like a silicon processor, but by pure geometric actuation? Are we simply the universe physically feeling its own shape?
Wow.
Just like those initials carved into the bark of a tree, the experience and the physical reality are one and the same, something to mull over as you go about your day. Until next time.